So by way of a quick review, this is an example of what I was just talking about, where the two vectors that you're adding are perpendicular to each other. Personally, I like drawing the horizontal first, so when you look at a map, west is to the left. So in anticipation of the fact that I'm going to then draw south, I think this is a good location to do it, because now from that point where I finish drawing that arrow, I need to draw an arrow south. So that's 120 kilometers west. Now I draw 100 kilometers south. As I said yesterday, you don't have to get out a ruler or drafting tools and make it precise. I like to draw it reasonably to scale, so I know that the south is only 100, the west is 120, so I made the south a little bit shorter. We really ought to label this as 120 kilometers and 100 kilometers. The tip-to-tail rule says that this is the total of the vectors, which makes sense because if this is displacement, that arrow is going to tell you where you end up relative to where you begin. So something that didn't come up yesterday, and I don't know if it's going to be a source of error for some of you, but the angle in your triangle always needs to be inserted at the beginning of the diagram. You don't want to put an angle down here. That's not right. That's not the direction that arrow is pointing. When I talk about the direction something is pointing, you look at where it is at the beginning and which direction it's pointing away from. So your angle is always going to be in the corner that has no arrowheads, I guess. And as I said yesterday, each of these lines needs an arrowhead. So how do we determine the magnitude of that total displacement? Well, the total displacement is a vector. I'm saying, how do we determine the magnitude of it? Well, it's the hypotenuse. And again, just for me right now, being in teaching mode and you being in learning mode, I feel as though I shouldn't have to write down 100 squared plus 120 squared equals hypotenuse squared. That is at this level, a trivial calculation. Now, if I gave you a written response assignment or something along those lines and I said, I want to see your work, yeah, you would have to show that. As simple as that is to you, you need to show it if you're asked to show work. So what do we get? We get 100 squared plus 120 squared. I take the square root of my answer, and I get a magnitude of about 156 kilometers. And that means my displacement is going to be 156 kilometers. That's the magnitude part. And now we need to put the direction. And the direction will be so many degrees south of west. If you draw your horizontal first, then the letters will be written in the order vertical of horizontal. North of east, north of west, south of east, south of west. You can feel free to draw it in the opposite order. Draw your vertical first, but then you're going to end up with something that says west of south. Just be very careful about that. By the time you get to 30, sometimes answers on multiple choices will be west of south. But I like to limit it to south of or north of in this course until you get really used to the directions. So how do I determine that angle? I mean, this is the angle we're talking about here, right? Theta. Well, I use tangent. Tangent of that angle will be equal to opposite over adjacent, and that means theta is equal to the inverse tangent of 100 over 120. Just make sure I got that right. Opposite, yep. Make sure your calculator is in degree mode. I haven't reset my calculator lately, so I think it should still be in degree mode. So we got about 40 degrees. I don't care about significant figures for this. I'll go 39.8. Rather than writing 39.8 south of west, I'm going to, on this diagram here for you, show you using blue arrows what your purple arrows, what your diagram would have looked like if you drew vertical first. You would have started at this point and drawn a vertical arrow south and then a horizontal arrow west. And this would have been 100 and this would have been 120 kilograms. You still would have drawn the hypotenuse from the beginning of the blue diagram to the end of the blue diagram, and it would be the same hypotenuse, so you would still get 156, right? We know, by the way, I'm just going to say 40 degrees. You know that if that's 40 degrees, this is 50 degrees, because they add up to 90, right? But if you decided to draw the blue one, when you find your angle, you would have said tan of theta is opposite, and you would have written 120 over 100. So I would get 50.19. Which you could have done by taking 90 minus 39.8, but once again, I'm assuming that you drew the blue one because that's what you drew. The only difference is this would be 50.2 degrees. It would be west of south. Finally, could you have used RCS? Well, if I superimpose on this a coordinate grid, the RCS angle is the rotation angle that starts here and takes me to that arm. I call it an arm because that's what we call it in math. So how many degrees is that? Well, it's 180 degrees to this location, and then I have to go 40 more, which is why the answer says 220 degrees RCS.